All right, with this one, we're going to be revolving this around the x-axis this time. And if I revolve it, it's going to look something like this. It's going to have like this. That wasn't worth it, but whatever. So what I can do is I can revolve this one piece right here, and I'm going to revolve just this piece. And if I revolve just this piece, you end up getting this disc-looking thing with some sort of a thickness. And if you notice, it's going to be, so if I take this, let's take this, and we rotate it, it looks like a circle, like a circular disc with a radius of sine x, cosine x. And so the volume of this piece is going to be pi r squared. So it's going to be pi r squared, so sine x cosine x squared, and then multiplied by my little delta x. So this little change, so this little piece right here, this change. So this change right here, since we're on the x-axis, is going to be delta x. So we have that little change of delta x, which is right here. So if I add up every single one of these disks, because there's going to be an infinitely many of these, I'm going to have the integral. Pi can go from the outside, and we get the sine squared of x, cosine squared of x, and then delta x becomes dx once you get infinitely small. And we're going to go from 0 to wherever it hits the x-axis again. Well, where this is going to hit the x-axis, that's where it's going to be sine of x, cosine of x equals 0. And that either means sine of x equals 0 or cosine of x equals 0. So it's whoever hits 0 first over here. Well, sine ends up hitting 0 next over at pi. But cosine hits 0 at pi halves, so it will be first to hit 0. So it's going to be from 0 to pi halves. And then now I need to know how to integrate this. And if you remember, anytime we have sine squared, we can't really do anything about it unless we have a cosine here. But if I do a u substitution of sine, du will be cosine, which I only have one. I don't have two of them, so that's not going to work. So anytime we have a sine squared or a cosine squared, we always want to use our power reducing formula. And our power reducing formula is going to be, this is going to be 0 to pi halves. Well, sine squared of x, its power reducing formula is 1 minus the cosine of x over 2 of 2x. That's right, 2x. 2x. And then cosine squared of x is going to be 1 plus cosine of 2x over 2. And this is going to be dx. And so if we actually distribute this out, we end up getting 4 on the bottom. So I'm going to take that 4 and pull it up front. So it gets pi over 4. Integral from 0 to pi halves. And then this is a difference of squares, so I can actually just say 1 minus cosine squared of 2x dx. Now what we can do is we know that sine squared of x plus cosine squared of x equals 1. And if I subtract cosine squared of x to both sides, I get sine squared of x equals 1 minus cosine squared of x. So I can actually change this to be just sine squared of 2x dx. Now I need to use another power reducing formula. And the power reducing formula for sine squared of 2x is going to be 1 minus the cosine of 2 of 2x all over 2, which then gives me, if I pull this 2 out, you end up getting pi eighths, integral from 0 to pi halves, of 1 minus cosine of 4x dx. And then I think that you can actually do the rest of this. Good luck.